Hello friends, now we are going to discuss about the conductometric titration of mixture of strong acid and weak acid versus strong base. Here, in the mixture of strong acid and weak acid, HCl is a strong acid and acetic acid is a weak acid. This mixture is taken in the beaker and NaOH is taken in the burette. In the mixture of HCl and acetic acid, HCl is strong acid because HCl dissociate completely and acetic acid dissociate partially. Whatever this acid mixture is taken in the beaker, in that initially conductivity cell is dipped and we are going to note down the first conductance of the acid mixture. Then we are going to add the NaOH. When we are going to add the NaOH into the beaker, NaOH first react with HCl because it will dissociate completely and it will produce H plus ion, and it is going to produce the NaCl and water. When it will produce the NaCl and water, the highly mobilized H plus ions are replaced by low mobilized Na plus ion. Because of that, the conductance of the solution goes on decreased. Initially, the dissociation of acetic acid is suppressed due to common ion effect. When the H plus ions of HCl are completely neutralized, at that point acetic acid will come in action. And that point, whatever the NaOH we are going to add, it is going to react with acetic acid and it is going to produce the sodium acetate. Here mobility is slightly increased because of initially we are neutralized the H plus ions by using the Na plus ion, so that conductivity here decreased. But when the NaOH starts the reaction with acetic acid, that time conductivity is increase in the conductivity is observed due to number of Na plus ions are increased here. Because of that, slightly increase in the conductivity is observed. When acetic acid is neutralized completely, at that point there is a whatever the NaOH we are going to add, it will remain as it is, so that OH minus, because of the OH minus ion, we are going to observe the sudden increase in the conductivity. Then we are going to draw the graph specific conductivity versus volume of NaOH. Initially we are going to observe that conductivity is decreased due to it. At this point NaOH is going to react with HCl, so that highly mobilized H plus ions are replaced by low mobilized Na plus ion, so that conductivity is decreased. At this point the NaOH now start react with acetic acid, but here conductivity slightly increased because here already Na plus ions are there in the beaker. Now whatever the NaOH we are going to add, it is going to react with acetic acid and it is going to produce a sodium acetate. In that, because of the increase in the Na plus ion number, so that we are going to observe there is a slight increase in the conductivity. Then at one point where acetic acid is completely neutralized, and further NaOH whatever we are going to add, it will remain as it is in the form of Na plus and OH minus ion. Because of unreacted OH minus ion, we are going to observe the increase in conductivity. When we are going to draw the graph, we are going to get the two interactions. First interaction is that it is the neutralization for strong acid, that is HCl. Second interaction is V2 is for it is the neutralization of entire acid mixture, because from this point to V2 we are going to neutralize the acid mixture. Then by taking the difference between V2 and V1, we are going to obtain the end point for neutralization of acetic acid, where V1 is volume of NaOH required for the neutralization of HCl and V2 is the volume of NaOH required for the neutralization of acetic acid.